guys, Miss Kulkarni here. So guess what? In this video, we will discuss more about Proton NMR spectrum and how the details given could be used to derive the structural formula of an organic compound. So basically, we need to follow the steps in analyzing the NMR spectrum, which we had discussed in one of the video earlier. Let's review one more time. Number one, we need to identify any relevant information given in that problem. Sometimes the information may not seem to be directly related, but it may have some hidden pieces which can lead to functional group, or maybe even it can be some application use of that particular product. So always keep an eye on such information. Next thing is we need to make sure we do careful observation of that Proton NMR. What do you mean by that? That means we need to look at the signals, or we call commonly the peaks. And of course, last thing is we need to do the careful analysis of that Proton NMR spectrum. Alright, let's go into still more detail. When we say we need to analyze the NMR spectrum and look at the peaks, what exactly we are looking for? First of all, we need to identify the signal's peaks. How many is an important information. Okay, so note down how many peaks are there in the NMR. Then you should find out the integration ratio of the peaks, because that will give you some more information about the groups or the environments. Then we can find out the chemical shift of the peaks, which is very important, where the peaks appear, and that can also confirm the groups which we may have in our compound. Then this actually is one level going deeper, splitting pattern. Is it a doublet, triplet, it's a multiplet? That provides you information about the neighboring hydrogen atoms. And now after that, we can do the careful analysis of that NMR spectrum and pretty much arrive at the structure of that unknown compound. So are you ready to solve this Proton NMR puzzle and find out what is the structural formula of a given compound? Let's look at the details in the problem. We know that it has a molecular formula of C7H14O. Mark that oxygen there. That means we probably have either OH or carbonyl or ether or ester. So you need to figure that out when we are working on analyzing the NMR spectrum. Alright, here we go guys. So first of all, we need to find number of peaks. That's simple. You can clearly see that we have 3 peaks in this NMR. Next step is to find out integration, and just take a ruler and measure each of these integration areas. So let's see how much you find out. And this is what we got. So our ratio will be 0.6 to 1.0 to 3.0. And we need to find out these as a ratio of the integers, because protons cannot be the fraction. So if you look carefully, 1 is 1/3 of 3 and 0.6 is 2/3 of 1. I'm just saying sometimes mental math helps quickly to decide the ratio in the form of integers. So I can tell you this ratio is approximately roughly as 2 to 3 to 9. And just quickly let's add that 9 plus 3 plus 2. And how much that is? That comes out as 14. So probably we got the right proportion over here. Let's write down the integration ratio. That is 2 to 3 to 9. Now the splitting. Look at the peaks. And ta-da! All the peaks are singlets. Wow, that's kind of interesting that all the peaks are singlets. And now let's look at the position, and I prefer to label the peaks as A, B and C. So peak A is roughly about at 1.0. Peak B is beyond 2 a little bit, so I can say it's 2.1, and peak C is further downfield, which probably you can say it's close to 2.3. This is just a rough approximation because we don't have the fine scale given to us for NMR, but that will be good enough to determine the structure. So that's summarizing the information which you got. There is one more piece of information given to us, and that is about the IR. The IR spectrum shows a stretching at 1710. What is the stretch for? That stretch corresponds to a carbonyl group. So we got one more piece of information. Now, we have to put everything together and see if it all matches and we can get the structure. Okay, so this is the information we collected so far. That's the molecular formula, then we got the integration, and we also know there is a carbonyl group. So to begin with the structure writing, we need to put carbonyl group first. And we need to have now 6 more carbon atoms, 14 hydrogen atoms, and we already took care of oxygen by writing carbonyl. So what's the next step to go for? The integration is going to help us here. The ratio is 2 to 3 to 9. So we probably have, and again, we are already guessing this. It may be correct, it may not be correct. We are going to confirm that with the structure. So we probably have a CH2 group that matches with 2. With 3, probably we have a CH3 group somewhere. And then with 9 over here, we probably have 3 CH3 groups. And now we are going to put these around this carbonyl group. Look carefully, we got all singlets. Keep in mind, we should not be having any neighboring carbon with hydrogen atoms there. So I'm going to just put over here directly CH3. That will tell me that this will be a singlet. Now let's take care of CH2 group over here. And now the only groups remaining are these 3 methyl groups and 1 carbon atom. So how about if I write down 1 carbon atom and all these methyl groups linked to that. Okay, and that one, if you look at the structure, it matches with the molecular formula. It will match with the integration also because that will be 1 peak. This will be our second peak, and all these methyl groups, hydrogen protons, will give 1 peak. So we are going to get 3 peaks with this structure. Now let's justify that they will be all singlets. This methyl group over here has carbon without any directly linked hydrogen atoms. That means this will be a singlet. How about this CH2? This carbon and the other one carbon, both sides, they don't have any directly linked hydrogen atoms. That means that will be a singlet too. And these 3 methyl groups, 9 protons, are linked to this 1 carbon atom which does not have any extra other hydrogen atoms or protons. So here is our NMR with peaks A, B and C with the integration ratio of 2 to 3 to 9, and that's our structure. This will correspond to 1 peak, that CH2 will be next peak, and these 9 hydrogen atoms or 3 methyl groups will correspond to another peak. This will be 9, this will be 2, and this will correspond to 3 hydrogen atoms. So we are good with the integration. Pretty much we can say this is peak A, this is going to be peak C, and this is going to be peak B based upon the integration. But let's look at the chemical shift. And A is at 1.0, which is matching for all the methyl groups linked to carbon directly. Then this is for C, and C comes around like 2.3. Why it is so downfilled? Because it is next to a carbonyl group. So that matches. And this one comes at say 2.1. And that matches for a methyl group next to a carbonyl group. So there you go. we could solve the puzzle by putting all the pieces together. Now, let me ask you one more question. Will there be other possible structures for the same molecular formula? And if the group given to you is carbonyl as a functional group? Okay, let's see what we can do. There could be more than one structures, but I just thought, what if I move that CH2 group to the right side? Just I move this to the right side. That will match with the molecular formula. It will give you 3 peaks still. But how could you rule out the structure if the NMR given to you was showing 3 singlets? What happens here? This CH3 group is coupling with this 2 protons. So that will show as a triplet. This group is coupling with 3, so that is going to show a multiplet. And of course, these 9 protons will still show a singlet. So your NMR is going to look totally different. The chemical shifts will be different too, and also the multiplets will be different, although the number of peaks will be still 3. So Proton NMR is a wonderful, powerful tool. And what I like about that is you can guess various structures, and then you can go ahead and see if the NMR spectrum is matching to the structure which you guessed. If you get it correct, bingo. And if not, start all over again. So I hope you guys enjoyed the video. We will have some more videos on NMR spectrum and also some other analytical tools coming up soon. So stay tuned. I hope you guys enjoyed the video, and I will see you again in next video. Until then, bye-bye.